Okay, I've wired up my adjustable LEDs now, so every LED has three wires going to it. Green one is the data line, the orangey red is the 5-volt power, and the white is the ground. So that's all done now. It looks like a lot because it is a lot, but the payback is there's only 3 cables going back to the lighting control module. So that will become apparent later that how easy it is to connect all this to the lighting control module. I haven't bothered putting the voltage and ground from the last LED back to the supply because it's quite a short run. But if you had a really long run of addressable LEDs, you might want to add in an additional power point just to help the load, as it were. So what I've done is I now have 3 outputs from my chain here, and what I've done is the green one is the data, which goes straight into the lighting control module, one of the outputs of that. The power and the ground, which have now turned into a yellow and a ready orange because that's the ones I had to hand, they are going to be plugged into the expansion board of the lighting control module because they will provide the power. So the little microprocessor, the ESP32, doesn't provide the power because it just wouldn't be able to handle this number of LEDs. So I put a DuPont connector on the end there because that would then go straight into the expansion board. Okay, what else? So as you can see, what I've done is I've actually numbered all the LEDs to give myself a chance of not making a mess when it comes to programming all this lot. So if, for argument's sake, you look there, I've got number 6 is it the ground floor of the hotel, and I've got number 7 is the fireplace in the hotel. So if you look at my schedule here, I've actually shown that just green. So these are now telling me which LED is which, so that when I come to program all this in the web user interface of the lighting control module, I know which order they need to go into because that is quite important. So there we go. So as you can probably see here, that I started off with a sequence and quite quickly it went out of sequence. So the beauty of doing it this way is I know exactly which LED does which, so I won't make any mistakes. Okay, so that's all good so far. What else am I going to do now? Right, now I'm going to put that on the back of the hair, and then I can start wiring up the lighting control module. And once I've done that, I can then program it. So let me do that now. Right, I've plugged all my wires into the lighting control module. And what I've done is I've screwed them into the little terminal, the little green terminal blocks there. Now what I've done is, because of the nature of this layout where I've had bits of wires coming from old projects, I've just used the most convenient terminal for each wire. So as per my original plan, that now no longer is correct in any shape or form. So what I've done is, as I've been putting my wires in, I've been making a note of which pin they go to. So when I come to program it, I know exactly what's what and I won't make any mistakes. So here, for example, argument's sake, I've got traffic light 1 red, that's in pin 25. Belisha beacon 1 is in pin 12. Belisha beacon 2 is in pin 13, and so on. So that's all now crystal clear for me to use to enter the data into the web user interface. That's great. So the addressable LEDs, there's only a single data cable, and that is going into pin number 27, which is great. So I'm now almost ready to start plugging in some modes for these functions. There's a couple of things I want to point out to you first of all. Right, okay, so we've got these here, and these are the power and ground supplies to our addressable LEDs and the street lights. And if you can remember, I said the street lights are being powered by a transistor. So that's that's going back to the pin, but the transistor and the addressable LEDs need their own source of power and their own source for ground. So what I've done is I put DuPont connectors on the end of there, and the reason why I've done that is because on this expansion board here there are rails, and there is a ground rail and there is a power rail. So I can use any of those to tap into power and ground. But there's a very important thing that we need to make sure we've got right to start with. When you've got this board, you'll probably see that, let me just try and zoom in, that little yellow jumper there, that set those power rails to 3.3 volts, which is fine if you've got things running off 3.3 volts like the OLED screen, which I'll talk about in a sec. But addressable LEDs must have, the addressable LEDs have to have 5 volts or they won't work properly. They'll come out with lots of weird colors and do really odd things. So these power rails, which is where I'm going to get my power for my addressable LEDs, have to be set to 5 volts. That's quite simple. All I need to do is just pull that off, put that on the other side of the jumper, like that. So now that jumper is set to 5 volts. So these power rails are now 5 volts, and that's great because I can just plug my DuPont connector in straight into there, and I have 5 volts for my addressable LEDs. That's great. They're not being powered by the lighting control module, by the ESP32. They're being powered by the board. So therefore, when we plug an external supply into our USB connector, we don't have to worry about overloading the lighting control module. If you remember, I said you really only want 1 or 2 LEDs being powered off the pins. Any more than that, then you need to think about transistors or other alternative ways of powering them, because you'll cause damage. So that's all good. There is one more thing I wanted to point out. Oh yes, the OLED screen. We will plug an OLED screen in, a little display screen, once we've just checked everything's working nicely. If you remember on my scheme here, I've left pins 21 and 22 free for the OLED, so I don't have to reassign anything because there's nothing assigned to them anyway. So that's great. But what I wanted to show you is on this board here, I can get it in focus, there are 4 pins here set up all perfectly for us. There's a ground, there's a 3.3 voltage, there's pin 21 and pin 22 all next to each other. So that's like a sort of serial bus connector which we can use to plug our OLED in, which is great. The other thing which I need to point out is if you have installed an OLED and your jumper is set to 3.3 volts and you're running it off one of these power rails, if you subsequently add addressable LEDs to your system, you will need to change the jumper to 5 volts. But if you've got your OLED plugged into 3.3 volts, this channel here, that becomes 5 volts and that will damage it. So best not to. So it's a very good idea to use these pins here for your OLED screen if you have one. What was the other thing I was going to say? Oh yes, whatever this is set to, if that's set to 5 volts now, whatever that's set to, it doesn't, the pins from the ESP32 microcontroller, they're always 3.3 volts. So whatever you've plugged those into, they won't change. It's just this jumper here will change what voltage is coming out of this red rail. I think that's it. Right, what I'm going to do now is, well, I think we're now ready to start putting some data in. We'll power this up. Fingers crossed nothing goes wrong. And then I can start actually assigning the pins to do jobs, which we've set up our jobs here as to what everything's going to do. And once we're happy that that's all working, I can then set up the addressable LEDs with their jobs. Okay, let's give that a go. Before I get going on assigning pins to do various jobs, one more thing I'm going to do, which is very convenient to do right now. This is my little OLED display screen, which is going to give us various information on what functions are happening and what the time is, what the railway time is. It's very easy to install. There's only, I should zoom in, there's 4 terminals on it. You've got the ground, the voltage, 3.3 volts, and the 2 buses, SCL and SDA. And SDL goes into pin number 22 and SDA into pin 21. So that's pretty easy to do, and I'm going to do that now. So all I've got is 4 little terminals on the back. I've got my 4 DuPont cables, and I'm going to plug that in now. Right, first things are we need to sign in to the lighting control module from our phone or tablet. I'm using a tablet because it's easier to see on the screen what I'm up to. So I've gone to my Wi-Fi settings, and I can see that I've got a control module there, and 2B20 is the actual identification for that individual control module in case you're using more than one. The reason why, if you're wondering why it's this signal control module and not lighting control module, I think it's because I've had so many things put through this iPad, it's getting a bit confused what is what. But I know this is 2B20 because I wrote that on the actual unit itself, so I know that's right. So I'm going to connect to that. I've already connected probably, let's just have a look. It's going to auto connect, so I've already connected, so I've already entered the password. In the user manual we put detailed instructions of how you need to log in, so we won't bother with too much of the detail. So I've logged into the signal control module, or the lighting control module in our case, and now I'm going to go to my browser and I'm going to enter the address for the web user interface, and again it will probably auto recognize this, but it's 192.168.4.1. So it's already come up there already, so I can just accept that. And there we are. So we're now in the initial screen of the lighting control module, and this is where we're going to do most of our work. What I'm going to do now is I'm going to put my phone in a holder because I probably want to use both hands to do this. So let's do that now. Right, it's not going to be easy for me to do this because I'm going to get my arms in the way and there's a lot of reflection from windows, so trying my best. So this is the initial screen of the lighting control module, and as you can see up here, this is telling me what the railway time is, and our system works on railway time. So railway time is a compressed day, and at the moment my railway day is set to 4 minutes, so it takes 4 minutes to run 24 hours, and that's obviously why the time is progressing quite quickly. That can be set to anything from 1 minute to 1440 minutes. In other words, it can run in completely real time if you wanted it to. What we got next? We got the OLED, which we'll deal with in a second. Then we have 2 second settings, so you can set how long you want your traffic light green phase to be. The common cathode signals is what we talked about earlier, and we will need to use that. Then we have a completely different jump from this button, which takes us into the NeoPixel management, which we'll deal with later. And then below that, we've got all our pins which are on our lighting control module. These are the 16 pins we talked about right at the start. And as you can see, they're currently set to off because we haven't told any to do any yet. So there's 16 of those. Note that also you'll see pin 21 and 22 on here, and I did say earlier that we can reconfigure those to do the OLED screen. And once we've done these pins, once we've set them to the OLED screen, those 2 pins will disappear. So if you have used those pins for a function and you add an OLED screen later, it's a good idea to set those pins back to off, otherwise it might cause confusion because they'll then be hidden when we activate the OLED screen. So what I'm going to do now is the OLED screen at the moment is up there, and that's just blank at the moment. So what I'm now going to do is activate that. So if I enable the OLED pins on that little green bit there with that, so if I tick that box, okay, so it's saying switch in pins 21 and 22, please wait. And what normally happens, it will either just, oh, there you go, it's restarted. So it's actually restarted itself. Sometimes you may need to reboot it. And what we'll see is that if we now scroll down, okay, pins 21 and 22 have now vanished. In other words, they're not assignable because we now used them for the OLED screen, which is exactly what's supposed to happen. So let's have a look at the OLED screen now. So if I look at the OLED screen, let me try and zoom in. It's now that wavy thing, if you can see it on your screen, is actually my phone and the screen interacting. It's not actually in real life. So that says, it tells me what the real time, the railway time is, which at the moment is 4 in the morning. It tells me what the railway day is set to, which is 4 minutes. And below that, there's a list of pins, which we will assign them to do a function. At the moment, none of them are assigned to do anything, which is why they're all blank. So we're now going to start putting some functions in, and let's see how that goes. Right, so the first pins that we've put on our crib sheet over here are the traffic lights and the Belisha beacons, and they're quite a good place to start because none of those have any timing issues. They just run completely automatically, and we haven't got to do anything. So the first pin we've allocated is pin 25 to traffic light 1, and that is red. So all I need to do is find pin 25, which is here, and I am going to assign that as traffic light number 1 red. I can adjust the brightness, but let's just leave that at the moment as where it is. And I don't know if you can now see that traffic light number 1 red is now come to life. Do the next one. Traffic light 1 amber is pin 26, which is this one here. So click on that. Pin 20, traffic light 1 amber, which is that one. And now we have an amber light on here. And now we do the final one. Traffic light 1 green is pin 14. 14, traffic light 1 green. Okay, and now we have a green light on. So I'll do the next two. So I've got traffic light 2 red is pin 2. So traffic light red pin 2. Just come on there. Traffic light 2 amber is pin 4. Traffic light 2 amber pin 4. Amber lights come on. Traffic light 2 green pin 16. 16, traffic light 2 green. Sorry, I just had to edit that video because my phone started ringing. So we've set our traffic lights to the correct colours and pins, but as you can probably see, they're not behaving themselves. And the reason why that is because they are common cathode signals. We mentioned this earlier, and our default in our system is common anode signals, and the reason why we chose that is because they seem to be the most popular made ones, common anodes, so it just saves someone a bit of a step if you buy them because they're normally going to be common anode. Anyway, ours are common cathode. So if we go to the top of the screen again, we've got this common cathode signals tick box, which is currently unticked. So if I tick that box and then I hit the save all settings at the bottom, our signals have now started behaving themselves. So we've got two signals are linked together and working in sequence. So that one's green at the moment. This one is red. That's gone to amber. That's gone to red. This will now go to red, amber and green, and that will carry on cycling forever and we don't have to touch that. So at the moment that green aspect is set to 7 seconds. So if we now look at our OLED screen, can you see now that we now have some information next to some of the pins, and that's telling me we've only got 2 characters to play around with because it's quite cramped in there. So that's telling me that pin number 2 is currently set to traffic light signal 2 red, and that's what those little symbols mean. And you'll also see the little coloured in circles next door to them, and that's telling me what LED is currently active, whether it's on or off. Okay, so now what we're going to do is we'll go back to our screen. We'll carry on entering some data. The next 2 are pretty straightforward because they're just Belisha beacons. So let me just hold that there for a sec.